Today's program becomes even more special with your gracious presence among us. I once again extend a heartfelt welcome to our esteemed chief guest, Mrs. Vimala Saravanan, Madam. Finally, I warmly welcome Mr. Chandrasekhar Raja, core scientist, REST Labs, and today's speaker, Mrs. Nathiya Murali, associate scientist, REST Labs. Welcome you, ma'am. I am Mrs. Sonia Sriram, and it is my privilege to host today's current affairs session. Such programs plays an important role in broadening our perspective and reminding us of the foundational ideas that continue to influence modern research and innovation. The topic for today's session is quantum computing, is signal processing, which leverages quantum algorithms and quantum machine learning to process complex signals efficiently. This enables faster pattern recognition, enhanced noise filtering, optimized prediction, and real-time decision making, transforming communication systems, medical imaging, and advanced industrial applications. To present this topic in detail, we are pleased to have Mrs. Nathiya Murali. Is an associate core research scientist at REST Labs in Kaveripattinam, Tamil Nadu, India. She holds a BSc in mathematics and is specialized in data analytics. Her research interests include analytical methods, and she has contributed to research publications and conferences in interdisciplinary domains. I now request Mrs. Nathiya Murali to take the stage and enlighten her with her thoughts. Thank you, and over to you, ma'am.
Thank you, Mrs. Sonia Sriram. Good afternoon to everyone. The topic I am going to talk about today, quantum computing. Quantum computing is an advanced field of computer science that uses the principle of quantum physics to perform computations. Unlike classical computers, which use bits as the smallest unit of data, quantum computers use quantum bits called as qubits. Classical bits can represent either 0 or 1 at a time, but qubits can represent 0 and 1 simultaneously. This unique property allows quantum computers to process a massive amount of information much faster than traditional computers for certain types of problems. Quantum computers is considered one of the most important future technologies because it has the potential to solve problems that are currently impossible or extremely time consuming for classical systems. The foundation of quantum computing is based on a laws of quantum mechanics, a branches of physics that explains the behavior of particles at atomic and subatomic levels. At this scale, particles behave very differently from objects in everyday life. Quantum machines introduce concepts such as superposition and quantum interferences, which are directly used in quantum computing. These principles allow quantum computers to perform multiple calculations at the same time and explore many possible solutions simultaneously. Because of this, quantum computing is not just a faster version of classical computing, but the completely different way they process information. One of the most important concept in quantum computing is superposition. In classical computing, a bit must be either 0 or 1. In quantum computing, a qubit can exist in a combination of both states at the same time. This means a qubit can represent multiple values simultaneously. When multiple qubits are used together, the system can represent a huge number of possible states at once. For example, while a classical computer would need to check each possibility one by one, a quantum computer can process all possibilities together. This gives quantum computers an exponential advance in speed for certain problems. Another key principle of quantum computing is entanglement. Entanglement is a special quantum phenomenon where two or more qubits become strongly connected to each other. When qubits are entangled, the state of one qubit instantly affects the state of the other, even if they are physically far apart. This properly allows quantum computers to coordinate information across qubits is a powerful way. Entanglement enables faster communication between qubits and improves the efficiency of quantum algorithms. It is one of the reasons why quantum computers can outperform classical computers in complex computations. Quantum interference is another important concept used in quantum computing. It helps in strengthening correct answer while reducing incorrect ones during computations. Quantum algorithms are designed in such a way that the probability of correct solution increases, while wrong solution cancels out. This makes quantum computing highly efficient for specific tasks such as optimization and searching large databases. These three principles, superposition, entanglement, and interference, form the backbone of quantum computing technologies. Quantum computers operate very differently from classical computers in terms of hardware. Classical computers use silicon-based transistors, while computers require special physical system to create a control qubits. These systems include superconducting circuits, ion and quantum dots. Qubits are extremely sensitive to their environment, and even small disturbance such as heat or electromagnetic noise can cause errors. To prevent this, quantum computers are often kept at extremely low temperature close to absolute zero. Maintaining stability and accuracy is one of the biggest challenges in building practical quantum computers. Quantum computing is not meant to replace classical compute. Instead, it is designed to solve specific types of problems much more efficiently. Problems in solving large dataset, complex simulations, and optimization take are ideal for quantum computing. For example, quantum computers can simulate molecular and chemical interaction accurately, which is very difficult for classical computers. This capability is especially useful in drug discovery, material science, and chemical engineering. By simulation molecular at the quantum level, scientists can develop new medicine and material faster and more accurately. As quantum computing advancement, the importance of cryptography and cyber security, efficiently presented in previous session by Mrs. Arunabigai Ramesh and Mrs. Chandrasekhar Raja, becomes even more pronounced. One of the most important applications of quantum computing is in cryptography and cyber security. Many modern encryption methods depend on the difficulty of solving mathematical problems such as factoring large numbers. Classical computers require a very long time to solve these problems, making encryption secure. However, quantum computers can solve such problem much faster using algorithm like Shor's algorithm. This has raised concerns about the security of current encryption systems. At the same time, quantum computing also enables the development of quantum cryptography, which offer extremely secure communication methods based on quantum principles. significant role in artificial intelligence and machine learning. Machine learning models require processing large amount of data and performing complex calculations. Quantum computers can speed up training process and improve optimization tasks. Quantum machine learning has a potential to enhance pattern recognition, data classification and decision-making process. Although this field is still in its early stages, it shows great promise for the future of intelligent systems. Despite its great potential, quantum computing faces several challenges. One major challenge is error corrections. Qubits are very fragile and can easily lose their quantum state due to environmental interference. A problem known as developing reliable error correction techniques is essential for building large-scale quantum computers. Another challenge is scalability. Current quantum computers have a limited number of qubits, and increasing this number while maintaining stability is extremely difficult. Additionally, quantum hardware is expensive and complex to maintain. Quantum computing is still in the research and development stage, but progress is being made repeatedly. Technology companies, research institutions and governments are investing heavily in the field. While fully powerful quantum computers may take years to become widely available, smaller quantum systems are already being used for research and experimentation. Hybrid systems that combine classical and quantum computing are also being developed to solve problems efficiently. Quantum computing is a revolutionary technology that has potential to transform science, technology and industry. By using the principle of quantum mechanics, quantum computers can solve complex problems much faster than classical computers. Concepts such as superposition, entanglement and quantum interference make quantum computing unique and powerful. Although there are challenges in hardware development, error correction and scalability, ongoing research continue to push the boundaries of what is possible. Quantum computing represents the future of advanced computation and is expected to play a major role of areas such as cybersecurity, healthcare, artificial intelligence and scientific research. Thank you everyone.
Thank you, Mr. Nathiya Murali, for the informative and insightful talk on quantum computing. The session clearly explained how quantum computing leverages quantum machines principles such as superposition, entanglement, and quantum interference to perform complex computations beyond the capability of classical systems. This discussion highlighted the role of qubits, quantum algorithms, and parallel processing in solving problems related to cryptography, optimization, artificial intelligence, and scientific simulations. The talk effectively emphasized the future impact of quantum computing in cybersecurity, healthcare, machine learning, and advanced research, making it highly engaged and enriching. We truly appreciate the time and effort you have taken to share your knowledge with us today. I am sure everyone here has gained a deeper understanding and inspiration from your speech. At the juncture, we would be honored to hear a few words from our core scientist, Mr. Chandrasekhar Raja. We kindly request you to share your valuable thoughts and insights on topic with us.
Thank you, Mrs. Sonia Sriram. Good afternoon, everyone. Mrs. Nathiya Murali has clearly explained how principles such as superposition, entanglement, quantum interference are reshaping the way we think about computation, security, and intelligent systems. As we have heard, quantum computing is no longer just a theoretical concept, but a rapidly evolving technology with a real-world implications ranging from cryptography, cybersecurity to artificial intelligence, healthcare, and optimization across industries. I would like to briefly highlight some points from this discussion. First, quantum computing represents a fundamental shift from classical computing. Through superposition and entanglement, qubits enable parallel computation, allowing complex system problems to be addressed in ways that are impossible for classical systems. While the potential applications, particularly in cryptography, artificial intelligence, optimization, and scientific research, are immense, challenges such as error correction, scalability, and hardware stability remain critical areas of ongoing research. Together, these aspects highlight why quantum computing is both a revolutionary and an evolving technology. With this in mind, I would like to conclude by reiterating that quantum computing holds immense promise, while continuing research and collaboration will be essential to realize its full potential. Thank you.
Thank you, Mr. Chandrasekhar Raja, for your valuable insights, and thank you to all your speakers for making today's session meaningful. At the juncture, we would be honored to hear a few words from your account and administration head, Mrs. Vimala Saravanan. We kindly request you share your valuable thoughts and insights on today's topic with us.
Thank you, Mrs. Sonia Sriram, for the opportunity. I would also to approach the insightful presentation by Mrs. Nathiya Murali, the points chair of the scoring fundamental for the discussion today. Proud of you, ma'am. Your guest Chandrasekhar Raja has also outlined the service important points as the subject that already been covered in the depth. I will focus the key points. Proud of you, sir. Quantum computing is a modern technology that uses the principles of quantum physical to process information, unlike classical computing that the big quantum computing, which can exist as 0 and 1 at same times. They are useful in areas such as cryptography, medicine, artificial intelligence, and optimization. Thank you.
Thank you, Mrs. Vimala Saravanan, madam, for your valuable insights. With this, we come to the conclusion of today's current affairs program. I sincerely thank everyone for your presence and cooperation. Thank you and have a pleasant afternoon.